So I am Martin Alderete. I'm from Argentina. I work as a software engineer in a company called Depsar, where I work mostly with Python in distributed systems. And also, I'm a teacher in the university, where I teach about innovation and cloud computing. So that you have my email address and my Twitter. I will upload the slide after the presentation, so you can go online and pick up the link on Twitter. So let's jump into the follow view, the angle view. Does anybody had a problem understanding that? It's a pretty straightforward view. You got a form, so the user submit the input data. You perform some validation check. If the check pass, you try to send an email, save the user, and we're happy, okay? It's okay? So remember, when we are working in the web, as quicker we reply, as better for the user perspective is. So that code has a problem that is, it's blocking. It means send registration email will block the whole process until we could continue. So until it finish, we're stuck there. Why? Because we have to communicate with an email server, with external services, or wherever. So that code is blocking. From the talk perspective, we try to avoid that, okay? So we have to try to move that function in a non-blocking way. But we cannot use threads, we cannot launch a subprocess, so we have to do something to move that work to another place. Why? Because it's freaking coupled to the request-response cycle, so we cannot finish the request until we finish the processing. We cannot move the job to another host. This is a bottleneck for sure. We can start to scale, will be an issue. The error handling will be not really dry, so we are going to start adding a lot of try excepts or retries around our code, and that is not good. So that's not scale, because heavy work must be outside of the request-response cycle. It must be outside. So then we can move a step forward and sink into a distributed system with the following abstraction. Instead of think our system as a whole application, we can go with some idea of microservices, but behind that, we have a distributed system. We can think we got a producer, we got a queue, and we got a consumer, like multi-thread application. It's a pretty easy paradigm. You have something creating messages, inserting them into a queue, and you got some other guy processing them, okay? So this is our abstraction, but we will try to do this with Django. So let's jump into the brokers. Brokers for the producer-consumer paradigm are just a buffer, an array, a list, wherever, but it's in memory. And since we had threads, we could share the memory space. But now we want to distribute our job into different hosts. So we have something to share. What have to share? We could share something using Redis, which is a key value in memory storage. We can use Rabbit. We can go to a disk storage as well as Mongo, as MySQL, or wherever. But the best performance will be if we use Redis or Rabbit or whatever, because it's in memory. The advantages are the brokers from outside looks like a queue, like a first in, first out queue, or looks like a Python dictionary, a key value. Allows us to decouple our system into a distributed system, which is what we want to achieve, okay? Allow us to communicate different kind of technologies. With this approach, we can have certain part of Python, certain parts in C++, certain parts in Golang. The languages don't matter because we have a distributed system and we got a queue to share the memory between them. So scaling with this approach looks like more easier or more natural, not easier, natural. But not everything is good. We have disadvantages. Our monolithic, freaking big project now is a distributed system. So it adds more complexity to our stack, needs more maintenance, needs monitoring, needs a lot of features to scale. So it's not just a trivial decision. You can go and say, okay, I go for a full microservices architecture just because. So with this theory, let's try to do some handmade work. What I propose is something I call the hardcore way to do publish subscriber. We can have a Django application or Django project. We can add some Redis cluster. Redis, like a node, is all the operation are atomics because it had a single thread, event-driven programming model, so don't care about that, will work. And our consumer will be Python, will be a process in another machine, in 100 machine, in 1,000 machine, doesn't matter. So our registration email, the previous one, could be split in something like this, the abstraction. You got a Redis connection, you create a JSON, so you create a dictionary with some kind of protocol where we add a command, which say send, and we add a keyword args with a payload. Then we create a JSON, and we use a special Redis function to say, okay, insert this JSON payload into an email queue. So Redis contains data structures, so we have a queue inside Redis, and we can append items to the Redis queue. Does anybody have any issues with this? Okay. So this way, when Django execute our code, will be freaking fast to insert the message into Redis and continue. So for the user's perspective, the email has been sent, but it hasn't. Who will have the responsibility of send the email or do our job is the processor, the consumer, which is another process executed in another machine. For example, something like this. We got a infinite loop, or kind of infinite, and we say, okay, try to pop something from the email queue. The message is none, no, okay, continue. Do some validations. Is the JSON valid? Is the format valid? Yes, okay. So deserialize the payload into a command and an argument protocol. It's a pretty simple protocol. Then try to get a worker process. That is like a tricky, it's a dispatch. You say, okay, I got this command, give me some handler, okay? If the handler is okay, execute the code. But this code is running in another machine. So from the user's perspective, the email had been sent, but until we execute this code, the email is not. Make sense? So this is pretty straightforward, but could be confusing because it's executed in another machine, and so it's running and running and running and just processing commands. A summary about this. It's simple, yes, but it's freaking complex at the same time because we have to add a lot of boilerplate code, we had to copy and paste, we had all the logic to send to attend the different commands in the same worker. It's independent from the framework? Yes. Decouple the system? Yes. Move the heavy work to another place? Yes. But we have to do everything from scratch. We have to do everything in every single project we create. So that is not right. We have to monitoring, we have to administrate, we have to create the tools to do that. So, could be used? Yes, could be. Is the recommended way? No. So let's one more step forward and introduce Celery. Does anybody use Celery? Few of you, cool. Celery is like a asynchronous task message. It could split your heavy work outside of a Python application, not only Django, and it's focused in real-time operations. So the idea is like the same abstraction I show you is inside Celery, but at scale. All the job is done. We don't have to worry about what happened in the middle. So let's go into Celery. Check this out. Python, some broker, and batteries include. Why batteries include? Because Celery adds a lot of magic for us. Then looks like the first approach, but with more power. Celery uses a protocol called AMQP, or also use Redis, or could use MongoDB. Doesn't matter for Celery, but AMQP is an awesome protocol for working with distributed system. For install Celery, pip install Celery, that's it. So Celery defines as a concept of application. So every project where we want to use Celery, we have to create an application. It's like a copy and paste. You have to add this code in your Django project or your Python script or your Python project. In the place you want to use Celery, you need at least this. You have to create an application called Celery. For more info, you can go to the docs. What Celery adds, Celery defines a concept of task. A task is a callable object, any Python object which could be called. It could be a function or could be an object with a underscore, underscore, call, underscore, underscore. The idea is that you register tasks inside the previous application by using a decorator called shared task. Basically, magic happens. You're ready to run. The task had two responsibilities. One of them is define what will happen when the task is called. And the other is how we will process this job. That is inside a task. It's not more in the worker, as the example before. A task is an object inside Celery which a lot of attributes. Some of them, of the more important ones, are the name, the queue, the max retry, the rate limit, the time limit, ignore results. You got a lot of them. You can go and check it out online. The idea is that if you take some attention to this, you will see rate limit, time limit, queue. So some kind of magic could happen there. And this is how a real world task look like in Celery. Take a few seconds to take a look. You will create a function which receives at least one argument, is user ID, and that function is decorated with a shared task. In that case, when we decorate a task with shared task, what we are doing that we are registering our task inside Celery. So Celery can receive messages for this task. The code inside is pretty straightforward. You got a Twitter manager, update tweets, that's all. Check this out. There's a special exception imported from Celery. What does mean is, soft time limit is, for example, in that case, we are going to use the network, and we are going to try to reach Twitter. But what happens if the connection goes down, Twitter is not attending requests? In that case, Celery will say, okay, you exceeded your time limit, which previously we specify upside. You see it at the top? So when we exceeded, in this case, 3 minutes, the task will raise an exception, which is a special section called soft time limit exceeded. In that case, we have 2 options: do nothing or perform some actions. In this case, I say, okay, clean up something, do whatever you can. But there are other exceptions. For example, what happens is the Twitter credentials are wrong. Or in that case, for example, it could be that Twitter is down or whatever your application needs. So you could say, okay, that kind of suck, because you have to raise another exception with the name of the function and a retry. So in that case, you say, okay, retry to do the whole work when you can. In that case, a message will be append to the Celery queue. In a future, we don't know when the function will be called again, because it's a queue, so we don't know when the function will be executed. That is the important concept. We have a queue, we append messages to say, hey, when you have some free time, execute this. And the other side, we have some consumer trying to consume those messages. So this is the retry, and this is a retry with a countdown. What countdown does is say, okay, try to execute this, but wait at least 2 minutes, because probably the network is too congested, so we have to wait. Make sense? This way, we had a lot of arguments, and those arguments match with the previous slide where we have a lot of arguments. So basically, we are configuring our task. The idea is that every single task needs different kinds of arguments, because it's not the same to go to Twitter, than go to LinkedIn, than do some math. Those are different kinds of tasks, and each one has his requirements. So you have to pay attention to your requirement before you use those arguments. A good one for Django is send your emails. If the task raises an exception, Django will send an email to the admins, so it's pretty good. Another cool feature of Celery is routing. Routing is a mechanism by which we can decide which queue should receive or will receive our message when a message is created. If you think, you can think that it's like a router, a switch where the package arrives and he decides where the package should be. So for example, you say all the message coming from the task A will go to the queue A, but all the package for the queue B will be to the queue B, and the others go to a default one. In that way, we are balancing our workloads, so we are scaling. We are preparing our source code for scaling. We are not using a whole queue full of messages, so all the workers will try to process the message in the same queue. This is a problem. Think about emails. Your system could be a queue just for emails, and another queue just for refresh the Twitter information related with your users. In that case, why will we mix the queues? It's better to have different queues. We can say, okay, right now I'm not going to process any email because my server needs more power to process the Twitter ones. So you stop one queue and you start processing the another one, sharing the workers. That is kind of advanced, but it's good to keep it in mind at the beginning that when you start, you have to try strategies, you have to think strategies to distribute your tasks. The idea is by type. You got a lot of notifications and such as email, text messaging, whatever. You have to try to group them together in a queue and all the computation in another queue, and that way you could scale. That is, in that way, it's made in the configuration. Take a look, it's just a dict, tuples of dict. And it's much better than hard-coded in the source code, the queue, because you had a queue attribute here. So it's much better to use the configuration. So if you need to do some change, you just go, change the configuration, restore your service, and that's it. Actually, you could have some kind of magic and say, all the weekends just change the configuration because I need to send more emails, and that's it. Okay, but how we call our task? Since our tasks now are not regular Python functions, they have a special attribute called delay, which is a pointer to our source code. At the end of the day, this is just the magic that Celery adds to create a message, send it into the queue, and serialize it. Okay, so you say, okay, in that case, you can say update tweets by user ID dot delay, and just pass a user ID and the keywords. And that's it. That method will use what you specify in your task when you create it. In this case, we'll use a whole bunch of the task, the attribute task. The other way is the long way. It's allow you to configure how you call a task. It's apply async, and you have the arguments, the keywords, and all the options you want to override. For example, in this case, I could say, okay, my soft time limit will be 10 minutes. So if I want to change that, I have to use apply async, and in the option dictionary, override that, okay? We are get used to use delay because if we have the requirement, it's fixed, but sometimes we need some flexibility and we need to apply async in some special cases, like corner cases or special days or bug fixing, something like that. And how we run the consumers. In the other approach, we had a special process who run and run and run. In this case, it's the same, but we don't have to code that process. That process is coded in Celery. And what it does is monitor the queue, it processes the message in the queues, and execute our task code. So this code will be executed by a Celery daemon called Celery. And how we launch it, we had a different way to launch it, but it's pretty straightforward. You just type Celery, -a, the project name, worker. That's it. The worker is running. But as you can see, you can configure some options like concurrency. Concurrency is how many workers I will launch to process my queues. For example, 10. With number 10, we will fork 10 multiprocessing instances. And in that case, we need CPU power to process them. Other case could be evenlet, -p. We can say, okay, instead of using multiprocessing, we need to use evenlet. Evenlet is a networking library to perform I/O operations really fast without threads. If we need to crawl, scrape, something like that, we need to go and use evenlet or greenlet. So Celery is prepared to do that. Or a nice feature is autoscaling. You could say autoscale equals 10, comma, whatever, and in that case, it will launch 3 workers, but on demand, without restart, it will increase the number of workers until reach the number 10. So this is amazing. We can have a cluster with auto-scaling activated just by doing dash autoscale equals our numbers. We can combine all the arguments, and we can do dash help and get a bunch of arguments, but I recommend to use autoscale and concurrency. Concurrency will depend on your pool. If you use Evenlet, you can increase the number, but if you use by default multiprocessing, you have at least the same number of CPUs as processor. If not, you will have a lot of content switching in your operating system. An amazing, or at least useful feature of Celery is the async result, or futures, or promise, as JavaScript call it. The idea is the task will be executed in a future, but when is the future? Today, tomorrow, two minutes later? We don't have exactly the exact time, so we need a mechanism to get the result back after the execution. Celery provides us a Celery result backend, which is just a storage for our results. So our task can execute something and store the result. And in a future, we could go and say, hey, which was the result for this specific task? And say, it was true, it was false, it was this string, wherever. We have to know how we process that result, the semantic of the result, but the result is there. Redis is supported, Memcache is supported, MongoDB is supported, and a lot of backends. You should have to configure Celery result backend, and that's it. Each backend will use different configuration because some of them are in memory, some of them are in disk. So you have to choose one. I recommend to use something in memory, like Redis or Rabbit. If you don't need result, just turn it off. That's it. How it works? It's pretty straightforward. Every time you send a message to execute a future task, it returns you an async result. That is an ID, like a hash. So using that hash, you can retrieve the task and ask to the async result, hey, what is the status? Hey, this result is ready to consume. Hey, has the task failed? The task successfully finished, and at the end, hey, give me the result. And this is so powerful because in the web, we don't have a state. So if we send an email and we want to, or whatever, we do some background job and we need the result in the future, the user could continue navigating the site, and at some point, a pop-up could appear and say, hey, your result was for the executed task was this one. And how? Because we can track the states of the task. That is really important. Celery has a state machine inside, has a fixed number of states, but you could add more states. That's pretty awesome. For more info, Celery.results. This is the same. This is how you call the task and start working with the async result. And this is how, from the async result, the hash, you retrieve the object. Other component of Celery is the Celery bit. Celery bit is a replies to cron. Nobody knows. I think yes, or at least is the replay for the Python word, because you don't have to worry about how you configure your cron in each box. So what it does is a periodical task scheduler. So it will start your task based on your schedule. You could say, for example, here, you could say, at midnight, past 1 minute after midnight, execute the task on the application orders, module task, name, conclude request. That's it. Or you could say, okay, every hour execute management task clean database. This is so powerful because you can handle your background job or your batch jobs just with a configuration. And if your tasks are like minimal, so small, you can reuse them. For executing the bit, it's just salary, -A, your project, and bit or worker. You can land, if you need to process, but you also need the bit, you have to launch 2 different processes. One is the worker, and the other is bit. That's important. Because bit just send messages back to the worker. An advanced feature of Celery is what Celery calls canvas. They're called canvas to a mechanism to group together the tasks, to chain tasks, to add callbacks in a JavaScript style. The idea is you have a small group of tasks, and you can add some behavior around them. For example, execute all of them in parallel with group. Or you can say execute the function A, when it finished, pass the result to the function B, when it finished, pass the result to the function D, and you have a chain, like a callback, or like a math composition. Another good one is the chord. The chord is a concurrency barrier. Does anybody know which is a barrier? Barrera? It's an idea is you have a bunch of tasks executing in parallel, but at the end you have to execute a final stage. So at the end you have to wait until all of them complete and then continue with all the results. That is pretty good. For example, you have to go and extract data from Twitter, Facebook, and LinkedIn. You can create a chore, execute them in parallel, and at the end, just grab the free result in a single function. So at that point, you had to wait, grab the free result, and pass them to the last function. This is kind of advanced and probably makes no sense at the beginning, but it's really useful. We have a distributed system. We need monitoring. Celery contains monitoring tools, but all of them are from terminal, and sometimes we need to monitor from our home PCs, not from the server. So I recommend Celery Flower. You can see it got graphs, stats, status, all that we need for tracking the life of our task and our workers. It's pretty good, actually. Yeah. What it does is real-time monitoring. It can progressa typo. It give us the progress and the historical progress of our task, details about the task, graph, stats, stat of the worker. We can say, okay, right now, auto-scale the workers. We can monitor which worker are live and which have died. We can see the executed status of a specific task. We can monitor in the queues. That a bunch of stuff could be done. Pretty easy to install. Pim install Flower. To start it, just Celery -a project Flower and a port. As you can see, it's a plugin. It's getting inside Celery, so you can think Celery support plugins, so you can write your own plugin for Celery. So, as thought and conclusion, I don't like to conclude nothing. Brokers or message broker came to stay. That's a reality. So we had to start working and thinking in distributed architectures. It allows system with flexible architecture, and it allows the communication with different technology. That is amazing, because Python is amazing, yes, but fit in all the problems? Probably not. So in that case, we can go and switch another technology and communicate it with Python. You can read the AMQP specification. What about distributed system? They are complex, but they can scale. They allow us to distribute the workload, our heavy work around the whole distributed system. Require maintenance and monitoring, yes, but we got the tools to do it, so there's no excuses to do it. Celery or distributed system are hard to debug. That's true, that's not a myth. But we can think strategies to isolate some kind of component and test them, and then run some kind of integration test or other strategies to see what's the healthiest status of our source code. Right now, with a distributed architecture or distributed system, we will have more services, but smaller. That's the new way, the hype of microservices. Welcome. And Celery is the framework. It's the framework for a Pythonista. So every single Pythonista have to try it, give it a try, and say, no, it's not for me, but try it. It's a mature project, so there is no strange behavior, so strange bugs. So the documentation is really good. I have been in contact with the author of Celery, and he is a really good guy. He is always willing to address you to the right solution. Celery is a word. It's really hard to understand it in deep. The source code is really big, so don't try it, not at the beginning. But it's really good and could be extended easily. That is easily because you need to know the internals. But it could be made by signals, management command, remote, a lot of feature. If you know something I'm not, please let me know. And in order to finish, I would like to propose a solution for something that is really common in distributed system. For example, you have to process a task, but you cannot have the same task more than once in the whole distributed system. How you achieve that? You cannot do a lock in the memory and say, hey, I own the lock? Yes, okay, execute. I own the lock? No, so wait. Because the memory is not shared. So we have to think strategies to centralize our locking and try to simulate multi-threading architecture in distributed system. A way to do that is using Redis. We can flag a value in Redis, like a lock, and just one worker can execute something in base to that. Sounds kind of weird, but I create a library. Actually, it's a GIST. You can check it out here. It's called Redis lock. The code is freaking easy. You acquire the lock, and you ask, I'm the owner of the lock? Yes, so execute the code. I'm not the owner of the lock? No, so another task is running, I do nothing, go to sleep. This is a recipe, you can use it, you can modify, you can send feedback, but the idea is that if you have the problem to ensure just one job at the time, there are solutions, and there is one pretty simple. This is the same, but using Django Cache. Pretty easy too. I like more this one, it's shorter and explicit. Okay? Preguntas.
Um, why do you prefer salary with EMP? I, no, red is another rabbit. Uh, why do you prefer salary with rabbit MQ instead Redis?
So the question was why I choose Rabbit instead of Redis. That is a good question, but I got a conceptual or theory behind that is that Redis doesn't support AMQP, the protocol, and Rabbit yes. And the AMQP specify how we could execute a task in a future, but we say when the future is. We can say execute this task just 3 days, 3 more days, 4 more days, that in a month, and in Redis is not possible. So a lot of details related with the AMQP protocol are not implemented at all in Redis. So in that cases, you need Rabbit. Another good feature of Rabbit is that you can ACK, you can say, hey, I just processed this task, and you can mark as processing. Redis is just a key value store. You put some payload, and you get it back. Make sense?
Great talk. So my question is, what is the state of the integration with Django? I think there was a different project, not sure if they merged or forked. How's that?
Before the Celery version 3, it means in the branch number 2, there was an issue, so you could not use Celery with Django just in a simple way. You need a third-party application called Django Celery, but in the version 3, and the latest version, they changed the way you communicate with Django, and they add the concept of application, so you don't need anymore the Django app, so Django Celery application. So if you have Celery version 3, just remove Celery Django application and create the application object, and that's it. No problem.
Well, for example, in that task that you show us that sends the email, so suppose that we use, I don't know, Mandrill or something like that, an external service. What if some unknown exception to be raised and our test code does not handle this exception, so we had a problem, we did not send the email, and we need to send the email. I don't know, it's a notification to the user that we received his payment for our store or our e-commerce. How do you do with this scenario?
That is a good question. Personally, in that kind of scenarios where you need to the state of the task, I go for sure for a backend result, and we try to get back the result, for example, once a day, twice per day, or whatever. And in production, I set the alert. So every time a task crash, it sends back an email with the traceback, Django style traceback. So as much I get 10, 20 emails and say, let's go and hotfix this. But you have to enable the alert for sure. Anyone? Okay, if you need to contact me, feel free. I'm on Twitter, or you can send me an email to that address, and just in 2 minutes I will upload the presentation so you can take a look and you can contact me later. I would like to say thank you to all of you because you stay here. I'm speaking in English. And to my company, Debsar, who support my travel from Argentina to Python Brasil. Obrigado.